section, we're going to be solving exponential and logarithmic equations. We'll begin with exponential equations. To solve exponential equations, we're going to be using a property that makes a lot of sense, having in mind that the exponential function is one-to-one function. If, let's say, 2 to the x is equal to 2 to the 2, it is common sense that x must be 2. If x is 3, then that's going to be 8, and that's 4, so obviously not correct. So the only way this to be true is x to be 2. So we are going to follow the steps to solve this equation. We're going to rewrite both sides of the equation in a form b to the m is equal to b to the n, and then we're gonna say, well, with the same base, then the exponents must be equal, and solve for the variable. So 3 to the x is equals to 243. I would like to know what is 243. Wait. So 3 to the 4th is equal to 81. So 3 to the 5th is equal to 243. So I'm going to rewrite this expression in terms of 3 to the x is equal to 3 to the 5. And then I'll say, well, the bases are the same, so we're going to drop them out. And x must be equal 5. So that's easy. The next problem, 4 to the 2x plus 1 is equal to 64. Well, I know that 4 times 4 times 4 is equal to 64. So this equation, 4 to the 2x plus 1 is going to be equal to 4 to the 3rd. So that's 4 to the 3rd. Having that in mind, I'm going to drop the base and say, well, then 2x plus 1 needs to be equal to 3. And from here, we're going to solve easy linear equations. Subtract 1 from both sides. 2x is equal to 3 minus 1, 2. Divide both sides by 2. X is equal to 1. And solve. Well, for all equations, it's very easy to check, so I recommend you checking your answers for your convenience, especially during exams. Check 4 power by 2 times 1 plus 1, is it equal to 64? Or 2 times 1 is 2 plus 1 is 3, and 4 to the 3rd indeed is equal to 64, so that's a correct answer. Now for question 3, it's a little bit challenging because 16 powered by nothing is 8. However, we know that 16 is equal to 2 times 2 times 2 times 2, which is 2 to the 4th, and 8 is equal to 2 times 2 times 2, which is 2 to the 3rd. So as long as we create the same base from both sides, we should be good to go. So 16, we said, is 2 to the 4th, and this needs to be powered by x. And 8, we said that was 2 to the 3rd. Now, based on properties of exponential function, this is the same as 2 powered by 4 times x. And 2 to the 3rd. Once we have the same base, we can cancel the base and make 4x equals to 3, which means x needs to be 3/4. Next example, 625 is equal to 25 squared, or 5 to the 4th. So 1 over 625 is going to be 5 powered by negative 4. So 5 to the 2 minus x is equal to 5 powered by negative 4. Again, the base is the same, so we can remove the base and solve the equation. 2 minus x is equal to negative 4. We subtract 2 from both sides. It's negative x is equal to negative 4 minus 2, or negative x is equal to negative 6. Divide both sides by negative 1, we end up having x is equal to 6. And that's our final answer. The next question. Again, 8 powered by nothing is 4, neither 4 powered by something is 8. However, 8 is equal to 2 to the third, and 4 is equal to 2 to the second. So we're going to say 2 to the third powered by x minus 2 is equal to 2 to the second powered by x minus 1. Again, based on properties of exponents, that's the same as 2 powered by 3 times x minus 2. And on the other side of the equation, that's the same as 2 times x minus 1. Now the bases are the same, so we can drop them. Then 3x minus 2 needs to be equal to 2 times x minus 1. Distribute the 3 and the 2. 3x, 3 times negative 2 is negative 6. 2 times x is 2x, and 2 times negative 1 is negative 2. Add 2x to both sides. Subtract 2x from both sides. Subtract the 2x and add the 6 to the other side. We'll end up having x is equal to 4. And that's our answer. Should I probably move it here so I can have more space for the next example. Then 5 powered by x plus 1, and 1/5 to become 5, that's the same as 5 powered by negative 1. Again, the base is the same, so x plus 1 needs to be negative 1. Subtract 1 from both sides. X is equal to negative 2 is our final answer. So solving exponential equation when the bases are similar can present us base powered by. It's extremely easy. However, not all problems are like that. Some of the exponential equations would be one side cannot be powered by nothing to be like the other side, neither the other side. No way to make 29 any base of 3. So what we do in this case is following the steps. Isolate the exponential expression. If it's not isolated, like in example 5, we are going to divide first both sides by 5. And our goal is to isolate the exponential expression as a first step. Then we're going to take common logarithm on both sides of the equation base 10. Or we can take natural logarithms of both sides of the equation, other than equations other than base 10. Then we are going to simplify using one of the following properties. The power rule for exponents, or calculate e powered by x is equal to e to the x, that's property of the logarithms, or 10 powered by x is equal to 10 to the x, again property of logarithms. So based on those, and then we're going to solve. So for example 7, I would like to take ln of both sides. So take or either natural logarithm or common logarithm. I'm going to take ln of both sides. Take ln of both sides. And it's it's going to be ln of 3 to the x is equal to ln of 29. And then I'm going to use the power rule, move the x in multiplication, ln of 3 is equal to ln of 29. And then this ln of 3 is a number. So if that was a problem, let's say 2x is equal to 3, what you're going to do to solve x is divide by 2 both sides and you're done. So this ln of 3 is just a number. So we're going to divide by ln of 3 both sides of this equation. And that will be x is equal to ln of 29 divided by ln of 3. And of course, we're going to calculate this. Bring my calculator. I'm gonna need it for these few questions. So ln of 29 divided by ln of 3, and this is 3.065. Another way to solve this problem is directly go to properties of exponents, especially if you have more advanced calculator. Directly apply logarithmic functions. I'm going to move it right here. I'm going to write that over here. So you can think, okay, I always start with the base, so that's logarithm base 3 of across the equal sign 29 is equal to across the equal sign x. And this is something that some calculators can calculate right away. So logarithm base 3 of 29, and you can calculate this way also. The next example, example 8. Here it's handy directly to apply that method that I just mentioned. You can go very fast going, okay, so the base is e, so convert this to logarithmic form. That's going to be ln base e, logarithm base e, always go across the equal sign of 2 is equal to x plus 5. And then solve for x plus 5 by subtracting, solve for x by subtracting 5 from both sides. So that's x is equal to ln of 2 minus 5. And that can be calculated also, ln of 2 minus 5. So that's negative 4.306853. We could have also take logarithm of both sides, and if we take logarithm of both sides, it's going to be, it's just a longer version of that example, ln of 2, then move the exponent in multiplication, ln of e is 1, and again get to the previous example, the previous case. So very nice. If it's exponential form, we're going to take logarithm of both sides and solve the problem. So we're gonna take ln of both sides, so ln of 2 power by x plus 8 is equal to ln of 5. Move the exponent in multiplication, x plus 8 times ln of 2 is equal to ln of 5. Divide by ln of 2 both sides. X plus 8 is equal to ln of 5 divided by ln of 2. And finally subtract 8 from both sides to receive the answer. X is ln of 5 divided by ln of 2 minus 8, which can be calculated. Ln of 5 divided by ln of, it's ln of 2 minus 8. And the result is negative 5.678072. Notice that I didn't round because there wasn't any recommendation for how to round, but when you do your homework, there would be special requirement round to the 4 digits after the decimal place. And if I want to round this to 4 digits after the decimal place, just as a reminder how we are rounding, if I round up to here, I'm looking at the next number, and if this number is 5, 6, 7, 8, or 9, I'm going to round up to negative 5.6781. But if this number is less than 5, 0, 1, 2, 3, or 4, I'm going to round to round down to 0. The next question, question 10. Again, first we need to solve for the exponential function, so we have to divide by 2 both sides. That's e power by 5 times x is equal to 1070 divided by 2. And then instead of applying the previous method, I can directly say, oh, this is logarithm based e of what? Across the equal sign, 1070 divided by 2 is equal to across the equal sign 5x, and divide both sides by 5. So x is logarithm, let's see, 1070 divided by 2 is 535. 535 divided by 5. So logarithm of 535 divided by 5 is equal to, and it's not exactly equal to, but rounded equal to, so I'm going to put a rounding sound here, 1.256453. Notice that this is completely not the same as 535 divided by 5. Based on previous lessons, previous properties, that's completely different thing. So make sure you divide the entire logarithm by 5. If you're using graphing calculator or the scientific calculator, I know you need to put parentheses around 535 and then divide by 5. The parenthesis is gonna 535. Okay, 535. Finally. So see how this answer is the same as that one here, because I closed my parentheses. And with this, I'm gonna conclude this video.